Do we get in the results today?
Ah, yes. Your results, I forgot them. Oh, you were going to get them today, if I remembered, which I didn't, so sorry about that. Okay. You probably know this word already, average. Yes? But do you know what it is? How would you explain it? It's like something in the middle, isn't it? Yeah. So, the way we picture it is if our data was like a space, and we have all our data points, we think of the average as being some kind of point in the middle. But there are actually many ways to calculate this point. In fact, we can have something called the mean average, the median average, or the mode average. So, and there's actually a fourth one which I do, which I call the midpoint average. So I'll just write mid here. So we have 4 types of averages. Okay, so write those down, please. So we'll have a look at these 4. Each one has an advantage and disadvantage. It's not like one is right and one is wrong. They each have advantages and disadvantages. Okay. Okay, got that? Yeah. So I think I'll start with the one which you first learn in school, which is the mean average. So the mean of x1 dot 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 to xn. So x1, x2, these are your numbers. So what's the mean average here? Well, you add them all up. Yeah, the sum. And then what do you divide by?
Over the number of things.
Yeah, so in this case, what would that be? N. So that's the mean average. Or if you want, the sum from 1 to n xi over n. This is the one that you learn in elementary school, or at least middle school, the mean average. A lot of people, when they say average, this is what they are talking about, but we should be careful. We should always call this the mean average to make it different. Okay? Right. Can I go down? Yep. Right, so the next one, the median average. Yes, Malik, question? Ah, yes, so when we get to examples, I'll show you the advantages and disadvantages. So the median average. Does anybody know this one, the median average? Go for it, what is it then?
It's the middle upper point out of the middle point.
Oh, let's not use fancy words.
The middle point.
Yeah, the middle point, yeah. So what you do with the median is you sort them from the smallest x, whatever that one is, the x which is smallest, to the x which is largest, and then you take the middle x value so you just put them in order from smallest to largest, and you take whatever is in the middle. Now, this works nicely when you have an odd number, like for example, x1, x2, x3. So that's the median. Like for example, if I use the numbers, let's say 2, 6, 10. So 6 is the median. But you probably know what to do if you have an even number. Yeah, you take the middle 2 and add them and divide by 2, which you should remember from middle school as well. So that's the median. Next one, mode. Can I scroll down? Yeah. So the mode average, which one is that?
Highest, minus,
No, not this one now.
the smallest.
No, not this one.
Most frequent.
Most frequent.
Yeah, most frequent.
This one, yes. So this one, the mode average is the most common value of x. Now this doesn't always exist. So for example, if I have 2, 3, 3, the mode is 3. But if I have 2, 3, 4, there is no mode. It doesn't exist. So obviously this will be one disadvantage of the mode. It doesn't always exist.
You might have like different values as well. Like if you have your,
Everyone's different value.
you know, like 2, 2,
2, 2, 3, 3, 4, 4.
yeah.
Yeah, so what's the mode then? This is what we'll get to in a second for advantages and disadvantages, yeah?
I was going to ask for the previous one, the median
Yeah.
formula.
No, it's a procedure, a process. You sort them from smallest to biggest, and you just take what's in the middle of the list. So for example, the median height here in the room is I have everybody line up from shortest to tallest, and the median is the height in the middle. Yeah? Is that okay? Yeah? And the last one is the midpoint average. Does anyone know this one? It's just the smallest value of x plus the biggest value of x divided by 2. So it's like the shortest person plus the tallest person divided by 2. Let's see. Well, I'll show you in Excel first. So we'll do some examples, okay? So
What do you call the highest value minus the minimum value plus?
that's called, well, the highest minus the minimum is called the range. Yeah.
I think plus
Plus 1,
or minus 1.
minus 1. Don't know about this one. The biggest minus the smallest is called the range. Yeah. And actually we'll get to that in a different lesson as well. Yeah. Okay, so let's write down some numbers and calculate the mean, the median, the mode, and the midpoint. So, I don't know. 5, 5, 2, 7, 0, 1, 6, 9, 5, 5. Okay, so if you can just write this down, this is the data. So here is our data. There now. Did you write this list down? Are you sure? Should I believe you? I guess I should believe you. Okay, so the first one we'll calculate is the mean. So I want you to add these 10 numbers together and then divide by 10. So tell me what you get. You got a number? Yeah. So what did you get for your mean? 4.5, yeah. So the mean, we have to add up all the numbers that's 45, and then we divide by 10. So 4.5 is what you should get. Okay, if I want the median, what do I need to do? So I have to write them in order. What's the smallest number? 0. So we go 0, 1, 2, 5, 5, 5, 5, 6, 7, 9. Okay, so write them in order, please, from smallest to largest. Yep. So if I go from smallest to largest, the median, because there's 10 numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's going to be the 5th and 6th number, which is these two, which I'll highlight. So here, I know it's not going to matter, but it's really supposed to be 5 plus 5 divided by 2, which of course is still 5. I think it also makes it clear here what the mode is. What's the mode? 5. And finally, what the midpoint average is. Yeah, it's going to be 9, the biggest, or the smallest, plus the biggest divided by 2, which is 4.5. Notice how there's not much difference between the 4 answers. You see that?
Yeah.
They're all pretty similar. That's not an accident. A lot of data that you might get has this feature that the mean, the median, the mode, and the midpoint, they're all pretty similar. In fact, this data, it has a name when the data is like this. Does anyone know? It's a very difficult name. We call it normal. Yeah. So when the data has this feature that the mean, the median, the mode, and the midpoint, that they're all pretty similar, we call this data normally distributed, or just normal data. Not all data is like this, of course. I'll give you an example of data that is like this. So examples of data that is like this would be height, weight, things that you have to measure, height and weight. Would anybody know an example of data which is not normal?
Student grades.
Students' grades are actually normal. They usually have this feature. Yes, grades would be normal. It usually has this feature. Income is the example that is definitely not like this. And we'll look at an income example in a minute. Actually, you know what? I'll just change the numbers here to make them income. And then this will give us a talking about advantages and disadvantages. So I'm just going to change these numbers here. So I'll put them in order. When you talk about income, most people have a lot of money or a little money. Most people have a little money, but some people have a lot of money, of course. Basic economics, right? But these people that have a lot of money, they really have a lot of money. You know, it's not like they have a little bit more, they have a lot more. So for example, maybe you have some people on low income, 20,000 per year, so it's like 20,000, 20,000, 20,000, 20,000. Then we have some people on a kind of more, not 30, middle income. And then of course there's some kind of management people, so they might be on like, let's do another 30. They might be on 60, and then 60. But then the richest person, what would we give them?
60.
Like the richest person would be like 200 or 300 or maybe even 1 million. So we'll make them have 1 million. And maybe this person owns the other 9 people. Employee and employer, okay? Now actually let me just change that. you to have a look at how different now the averages are. So the mean is 129,000. The median is 30,000, the mode is 20,000, and the midpoint is 510,000. Now, if I told you, oh, these 10 people, they're quite wealthy because the average is 129,000, do you think that's an accurate summary? No, because 9 of them get much less than 129,000, and only 1 of them gets more than this. Okay? So when we talk about income, we shouldn't use the mean average, because the person down the bottom is making the average go up a lot. Which do you feel is the most accurate or the fairest average to use to describe people's income? You could say median or the mode, because the mode, most people have this income, so that's useful, because these are the most people with this, most people affected. But the median is also important because it puts the person in the middle, and you're saying that half the people will have less than this, and half the people will have more than this. So here the median is 30,000, that means half the people will have more, and half the people will have less than 30,000. And maybe you think this is good, okay? In some countries have a very, very big mean, and a very, very small median. What would that mean for the country, for its income? If the mean is very big and the median is very small, yeah? Huge inequality, yeah. So some countries, I think places like, I think Saudi Arabia has a very high one, and I think China as well is high. And
Russia.
Russia as well. What about, how's Brazil? Would it be high, would you say? You see, a lot of countries actually do have high inequality. There's a big difference between the two. But there are some countries with low inequality, that the median and the mean are more similar. What countries might they be? Would you know? UK, there'll still be a big difference, just like in Ireland as well. Sweden, Norway.
Germany.
Germany's okay, yeah, there'd be less of a difference as well. So, you've done income inequality in economics or business?
Not yet.
No. Have you done like people's income, or this is more macroeconomics, isn't it? And you've just done micro. Yeah. So anyway, one way you can measure income inequality is by looking at the mean and the median. The more different they are, the worse the problem is. You might want to write some little note down, because in the exam they might ask you a question like, what is the difference, or which one is better, or which one should you use? So it depends. Income, we should use median. That's an example of income. What's an example of when you should use mean? Yeah, so let's do one of each example. Median, you should use for income. Mean, what do you think? Height and weight and things like this. What about mode? So do you want an example where it's important to know what is the most common number? Probably something like maybe classroom size. Because if you're planning a classroom, you want to know what's the most common size classroom, then you should rent this size classroom, So mean would be height and weight, median would be income, mode would be something like classroom size, maybe. Classroom size. And what about mid? Any ideas? Well, the only real advantage for midpoint is to give you a very, very quick calculation of the average. Because for the midpoint, you only need the smallest and the biggest number, and you add them together and divide by 2. So the only use for midpoint is to have a quick estimate of the average. Do you understand? So for example, if I want to know the average height in this room, the midpoint would be a quick average I could do. I could ask for the shortest person and the tallest person, measure and divide by 2. This is a lot quicker than measuring everybody's height. Yeah. So the usefulness of the midpoint is that it's quick, and that's all. That's all. Okay, have you got these? Yeah.
But when you look just for averages without looking to the data,
Yeah.
you might get surprised with only the mean average.
What do you mean?
You don't know that the highest one is 1 million and...
Oh yeah, you need to know who's the biggest and the smallest is.
Yeah, it doesn't show you that.
Which doesn't?
Mean.
No, the mean doesn't. No. But what I'm saying is, if the data is normal, then the mean and the midpoint should be about the same. So this means that if you know who's the smallest and who's the largest, you can quickly estimate by using the midpoint. You know.
But only when data drops all the
Absolutely, yeah. If you had one really big data point, is that it?
Yeah.
Yep. Then everything's messed up. So that's what I mean by the data needs to be normal. That if you have a really big value, you have a really small value. Now, why is income not normal? Can you have people with really big incomes? Yes. Can you have people with really small incomes? Well, not really. The smallest income they could have is 0. They can't have negative income. Do you get what I'm saying? So you can have millionaire, billionaire, right? But you can't have negative millionaire and negative billionaire. So this is what I mean. The data is not normal. You know, it's not balanced. But you're right. If you had one really, really wealthy person, that would mess up everything, just like in life. Yeah. Okay. Now, there's another example we need to do. So this is what you do when the data is in a table. But what do you do if it's not in a table? We need to have a look at an example of data that's in a table. Okay, so we'll make up an example. We're measuring the heights of trees or something. So here's the height in centimeters. And this here is the frequency. How many trees have this height? So we'll keep it easy and just make 4 bins, 4 groups. So the first one will be 0 centimeters to, I don't know, we'll just say 9 centimeters, and then 10 centimeters to, let's say, 29 centimeters, and then 30 centimeters to, let's say, 49 centimeters, and then we'll say 50 centimeters to, something like 99 centimeters. And let's say the limit is 1 meter because then the tree gets cut down or something. So 1 meter is the limit. Right, so we'll say we'll have 2 of these, 4 of these, 3 of these, and 1 of these. Okay, so write this table down, please. Okay. Got this? Not yet. Yes? Okay, so I want to write it down here. Get rid of this thing. Okay, so we have height in centimeters and then we have frequency. So the first one was 0 to 9, was it?
Yeah.
Yeah, and the next one was 10 to 29. The next one, 30 to 49, 50 to 99. Okay, so what are the first frequency? What is it? 2, 4, 3, 1. Yeah, that's okay. Alright, so the first problem is we don't have the actual boundaries. So if the tree was 9.7, where would it go? 9.7. First or second? second. So we need to put in the boundary. So the first boundary is 0 to where? 9.5. And then the next one is 9.5 to 29.5. And then here 29.5 to 49.5. And then lastly 49.5 to 99.5. Okay. Now, the problem is here, we don't know the heights of the trees, do we? I mean, all we know, for example, are you on your phone, John Murray? Give me your phone. I can't trust you with it now. Yes. Okay, so the first example, we have two trees. What is the height of those two trees? Well, you don't know. You just know that they are more than 0 and less than 9.5. So if you were to estimate, if you were to make a guess, what would you guess their height to be? What would be a good guess? Would 0 be a good guess? No, and 9.5 wouldn't be a good guess. The middle, yeah, something like 4.25 or something. So we use something called the midpoints now to calculate the average. So the first one is 0 plus 9.5 divided by 2. 9.5 plus 29.5 divided by 2. 29.5 plus 49.5 divided by 2. And then 49.5 plus 99.5 divided by 2. Yep. Now I'll go back to this in one sec, don't worry. I just want to give you a little formula. So for example, if you had, let's say this is x and this is f. 0, 1, 2, 3, and let's say this is 2, 3, 4, 1. And I want the average. How many zeros do I have? 2 of them. How many ones? 3. And then here, 4 of them. And here, 3. So in total, what have I got? 10 numbers, isn't it? So if I wanted the average, I would add them all up and divide by 10. But a quick way to do it, you can see that, well, I have 2 of these, and 3 of these, and 4 of these, and 1 of these. So I could just do 2 multiply 0 plus 3 multiply 1 plus 4 multiply 2 plus 3 multiply 1 divided by 2 plus 3 plus 4 plus 1, because they repeat. In other words, you can use this formula if you haven't seen it before. The frequency multiplied by the number divided by the total frequency. So this is when you have a table and it's like x1, you have f of them. x2, you have f of them, etc. That's a quick way to calculate the average if they're repeated, if you have a frequency table. Maybe you probably have seen this before as well. Yeah? No? This is new? Nice, okay. But you understand the idea? Yeah? Okay. So if I go back to my example, how many 4.75 trees do I have? I have 2 of them. And 19.5, I have 4 of them. And 39.5, I have 3 of them. And 74.5, I have 1 of them. So it's, look, 2 of these, plus 4 of these, plus 3 of these, plus 1 of these, divided by how many trees? 10 trees. So 2 of these, 4 of these, 3 of these, 1 of these, add them up and divide by 10. Can you try and calculate that and see what you get? Okay, got an answer? Yeah. So I don't know the answer, but I can estimate and I can see if my guess is close to the true answer. So I think the smallest number, look, the smallest tree is 4.75 centimeters, and the biggest is 74.5. If I add these together, I get about 80, and if I divide by 2, I get about 40. So I'd say the average, my midpoint average is about 39. So how close is the real average?
Far away.
Way far away.
28.05.
Ah, okay, way far away there. So it's not normal there. Yeah. So what did you get? Alright, so let's just double check that. Equals 2 times this one plus 4 times this one plus 3 times this one plus, whoops, plus 1 times this one divided by 10. 28.05? That's what you got? Good, okay. What's the mode average? That's the mean average. What's the mode average? 19.5. Yeah. The midpoint, that is this one plus this one divided by 2, which is very different. And what about the median?
19.5.
19.5? No, I don't think so.
So they take an area 4, and you take 4 here.
Not quite. Nearly. But I wouldn't say this. Any ideas? Median?
Do you have to sort them?
It's hard to sort them, but you kind of have to sort them, yeah. 19.5?
Yeah.
For the median?
Yeah.
Are you sure? Yeah.
It's 19.5.
Yeah, okay, I suppose 19.5. Yes, okay. 19.5, because you have 10 numbers. The median should be between the 5th and 6th number, and the 5th and 6th number are both in here, because the first 2 are in here, and you have 3rd, 4th, 5th and 6th, they're both in here. But I suppose it is 19.5, but it should be closer to 30, yeah, because they're at the end of the bin. Yeah. But it's just an estimate for today. So yeah, okay, you're right, I'm sorry. 19.5. Because the 5th and 6th are in the second bin. The 5th and 6th are where the median are. Okay, so that's 19.5. In the exam, they like asking this question. They like giving you a table and asking you to calculate stuff like this from the table. In fact,
do we have to sort them in the exam, or just like
well,
yeah,
in the exam you can't sort these because they're in a table. But sometimes they do give you a question where yes, you have to sort them. So in section A, they usually give you a question where you have to sort them. And in section B, they usually give you a table question like this. Yeah? Okay, there's one last average to do. I think... Yeah. It's, maybe somebody's heard of it before. Weighted average. Has anybody heard of this before? Weighted average? So I'll give you a very good example of a weighted average.
Is it like 1 point something?
Oh, you'll see. You'll see. So you know in maths you have 4 graded pieces of work. You have your coursework 1. Let's say you got, 80%. End of semester 1, 70%. Coursework 2, 70%. End of semester 2, 60%. Is your final grade the average of these numbers?
No.
No. That would be nice. It's not that. Each number has a different weight. It's worth a different amount. Yes? How much is the first number worth?
10.
This one is worth 10%. This one? 10. This one? 10. And this one? 70. These are called the weights. And this is actually the data, the x. The weighted average is the weights multiplied by the x divided by total weight. That's the weighted average. So write this example down and we'll calculate it. Okay, and tell me what this student will get for their final grade. Got an answer?
Yes.
What did you get?
72.
72? 72%, yeah? Are you sure?
Yes.
72? Are you sure? That's good for the student, I guess. What did you get, Tony? Oh, no, that's even worse for him. 64 sounds more like it, yes. 64? Yeah, okay. Now, 64, okay. Yes, Tony? Yes? No question? Are you sure? Okay. An example of where you would have weighted averages is in economics. Have you done? No. You've done micro, yeah? So you've not done inflation?
Yeah.
No inflation. But you know this word, do you?
Yes.
You know inflation? Yeah. So, if you talk about inflation, I think everybody knows that different areas of the economy have different levels of inflation. So, for example, education, maybe the inflation for education is quite high. It could be, 10%. Food, well, if I think about Ireland, inflation for food there isn't any at the moment, really, 0%. And then of course you have, like medicine, and that is maybe more like, like 7% or something. And maybe you have energy, gas and electricity. What do you think about energy inflation? What number would you say in Ireland?
Minus.
It'd be a negative number, yes. What would we say? I don't know, like minus 5%. Yeah?
Too much.
Question? I'm using a word that maybe you don't know, but I think you know it. Inflation. Yeah? Now, when they want to calculate the total inflation for the economy, do you think they just add these numbers together and divide by 4?
No,
Well, no.
the size of the economic.
Yeah, it depends on the size of each piece. So, which do you think would get the most weight if I was to give weights to each of these?
In energy and food.
Yes, probably energy would be the biggest, wouldn't it? So, what would we say? 25%, or no, maybe more. Because you got gas, electricity, driving, heating, everything really. So we'll maybe make this 50%. We could make this 10%. This may be, I don't know.
It's not necessary for
10,
everyone.
yeah, food's probably important, isn't it? 30%. So my point is, you would use weighted averages when each piece has different level of importance. Can we think of anything in business that might have a weighted average? I can't really think for business. I think more profit.
Dividend for shareholders. Like how much shares do they have?
Ah, okay, yeah. Because each shareholder, so if you have like Anne, Barry, and Charlie, and they each have a dividend, we shouldn't add them and divide by 3 to get the average dividend, because each shareholder would have a different weight then, yeah. So that would be another example of weighted averages then. Notice how weighted averages is very similar to the frequency table. The formula is nearly the same. For weighted averages we have this, and for frequencies we have basically the same thing, except instead of frequencies, they're weights. You can see how there's a similar idea there. Yeah? Okay, now let me just check.
Can we go?
One sec. Right. Heads A, tails B. Tails B401.
Yeah.
Right, so I'll see you in B401. I'll have to get the projector and things. I'll see you there at 3 o'clock then. I won't have time to get them because I need to get the projector and pack up and things. I'll have to give them to you in your next class. Sorry. Look, you don't worry, Malik. You got a good result, so you relax.